Electrolysis, simply put, is the process of using electricity to split water into hydrogen and oxygen. In this video, we will explore how to set up the reaction using materials we have at home, and we will also learn what exactly happens. Before we start the experiment, we need to take some safety measures. Long hair has to be tied back, and we will also need a lab coat and protective goggles. The reaction can produce lye, an extreme base. We also need a pair of rubber gloves because the experiment involves electricity. The materials we'll use for the experiment are water, salt, 2 pencils, a container, vinegar, and batteries and conductive wires. We need water to have a higher conductivity for this experiment, so we will dissolve some salt, NaCl, into it as well. The ideal ratio of water to salt for electrolysis is 10% salt and 90% water. So I've measured out 400 milliliters of water and 40 grams of salt. Now we mix until the salt dissolves in solution. Next, we place our pencils into the solution so that one end sticks out and the other end touches the salt water. Now we will connect the batteries to start the electricity transfer to the solution through the 2 pencils. I have 2 wires and 2 sets of batteries. Notice that I have attached one end of the first wire to a pencil and the other end to the positive terminal of the first set of batteries. I have attached one end of the other wire to the other pencil and the other end to the negative terminal of the second set of batteries. As you can see, bubbles are forming on the ends of the pencils. This is caused by the flow of electrons through the saltwater solution and battery system. The H2O and NaCl molecules of the initial saltwater solution have their bonds split by the electricity, and they rearrange to become molecules of hydrogen gas, chlorine gas, sodium hydroxide, and water. Let's take a closer look at each pencil and set of batteries. In the first set of batteries, electrons are flowing toward the positive terminal of the batteries. This, of course, is because the negatively charged electrons are attracted to the positive charge. The electrons leave the anode, or the first pencil, to get to the positive terminal of the connected battery, and a process called oxidation takes place. The oxidation reaction is the following. Chlorine gas is released, and this is what causes bubbles to form at the first pencil. Meanwhile, the cathode is being fueled with electrons that are flowing away from the negative terminal of the second set of batteries and into the solution. The negatively charged electrons are being repelled by the negative charge of the battery. This brings about a process called reduction, which splits H2O into hydrogen gas, and this creates bubbles as well. Now that we have finished our experiment, we have to know how to properly dispose of the saltwater solution. A reaction like this, that involves electricity and NaCl, can create NaOH, lye, an extreme base that should never be poured out without being neutralized first. We will pour some vinegar, an acid, into the solution to neutralize the base, and now we'll pour out the solution, while diluting it with water every now and then.